In this lesson, we are going to investigate representation of different functions on the same system of axes. That is to say, we are going to represent this function on the same Cartesian plane. We are going to have a look at three functions. The linear function, y is equal to 2/3 x minus 2. That is the first one. The second one will be the parabola y is x squared plus 1. And the third one will be hyperbola in the form of f of x, where equal to 2x minus 1. Now, with the linear function in the standard form, this is standard form, you shall remember this is y is mx plus c. This is standard form. Now, this function here, one, we need to get the x-intercept. And the y-intercept. Then you can draw a graph. Let's start with the x-intercept. We put y is equal to 0. That's going to be 0 is equal to 2/3x minus 2, which means 2 will equal to x. Our aim is to solve for x, so we multiply by the reciprocal of 3/2, which is 3/2. What you do on the left of the equation, you equal to on the right. Therefore, our x will equal to 2 will drop with the 2. X will equal to 3 in a coordinate form. X is 3, y is 0. That is the x-intercept. And the y-intercept we let x is equal to 0. And then from that equation there, we have y multiplied by 2/3, x is a 0, minus 2, y will be negative 2. So x is a 0, y is a minus 2. We are going to draw this graph. I'm going to draw this graph here. We are going to draw this graph here. And we are going to label that. One is here. 2 there, 3 there, minus 1 here, minus 2 there, minus 3 there, 1 is there, 2 is there, 3 is there, minus 1 is there, minus 2, minus 3. This is the x is the y. According to this, x is 3, y is 0. The coordinate is here. X is minus 2, minus x0, y is minus 2. The graph is there. We can join these 2 points here. Draw that. There is your linear function on your Cartesian plane. Right. Now we need to draw this parabola here. Now, from what the initial graph we had in the previous lecture was y is x squared, which was that. Now this one is y is equal to x squared plus 1. And then this, it means, that is to say, q is equal to 1. So we expect the graph, this graph here, to go 1 unit up. So on this Cartesian plane, we expect that graph to go through there. Now we are left with a hyperbola. That hyperbola is f of x is equal to 2 over x minus 1. Now our q here is minus 1, and we agree that this is the y asymptote. This is the y asymptote. So if we go back, we expect the function never to touch minus 1 there. And then you know that x as well cannot equal to 0. So the graph is going to go here, is going to go here, but pass the x-axis somewhere, and then we can solve. You see it's going down, so pass the x-axis at y is equal to 0. So 1 will equal to 2 over x, same as 1 over 1. By invertendo, we have 1 over 1. Therefore, x will equal to 2. Therefore, we can say that is going to pass here as it comes. It's going to pass here, but never touch -1. And then it must also come here, never touch -1, never touch x equal to 0. X is x 0 becomes our x asymptote, -1 becomes our y asymptote. This is how we draw the functions. Now, let's take it further into another field of discussion. The hyperbola and the straight line meet at this point here and at this point here. And where the two functions meet, the two functions are equal. We can call that A, call that B, call that C. Point A and B, at point A, and B, the two functions are equal, which means 2 over x minus 1 is equal to the straight line, which is 2 over 3x minus 2. The two functions are equal at A and B. At C, it is only the parabola which is equal to the hyperbola. So at C, the second equation, which is the parabola, is equal to the third equation, the third function, which is a hyperbola. Hope you got that. We'll meet in the next class. Goodbye.